Sometimes, the cleanest way to crack a hard probability is to break it into simpler cases first. That's the whole idea behind the law of total probability. Start by splitting the entire sample space into a handful of cases. Call them B1, B2, and B3. They have to cover every possibility, with no overlap between them. That's called a partition. Now suppose some event A cuts across several of these cases at once, showing up partly in each. A lives partly in B1, partly in B2, and partly in B3. To find the overall probability of A, you just add up A's share of every single case. A's share of a case is the chance of A within that case, times how likely the case is, P of A given BI times P of BI. Sum that over every case, and you have the total probability of A. Here's a concrete version. A factory has 3 machines. Machine 1 makes half of all the bulbs with a 2% defect rate. Machine 2 makes 30% at 3% defective. Machine 3 makes the last 20% at 5%. What fraction of all bulbs are defective? Weight each machine's defect rate by its share and add them up. 0.5 times 0.02 plus 0.3 times 0.03 plus 0.2 times 0.05. That comes out to 2.9% overall, each machine's contribution, weighted by how much of the total it actually makes. And you've already used this idea. Remember Bayes' theorem and that denominator, the overall chance of testing positive? Expand it out, and it is exactly a law of total probability sum over 2 cases, having the disease and not having it. That denominator was a total probability sum all along. Split the sample space into non-overlapping cases. Weight each case by how likely it is. Then add up A's share of every one. That's the whole law.